Hello and welcome to this video on part 1 of Symbols and Translation. This is section 6.1 of our textbook. What we're going to start to do in this chapter, in the whole chapter, is go from language, which in this case basically means statements, into formal or symbolic terms. So in the end we're going to basically formalize statements, and then eventually we will formalize arguments. And formalizing here basically just means putting them in symbolic terms, and so we will no longer see them as just as statements in a linguistic sense, where we can actually read out the words. Okay, so the idea here is the idea of form and content. That's the kind of abstract, general philosophical idea. And this idea of form and content we actually encounter in a lot of other places. So one place in which we encounter the idea of form and content is in poetry. Here is the form of a Shakespearean sonnet. A sonnet is a 14-line poem. And notice that the letters on the left, bottom left there, A, B, C, D, EF, EF, and GG are the formal way of expressing the rhyme pattern, as well as how many quatrains there are in the whole poem. So this is a formal representation of a sonnet. And then if we want to talk about content, we can actually look at a sonnet. Here is one of Shakespeare's most famous sonnet, number 18, and here we actually have content. So we just saw the form of this sonnet. Here we're looking at the content. The content, as you can see, is actually sentences, languages that express something. The distinction between form and content is also found in mathematics, except that in mathematics we have numbers for content. So here we have the Pythagorean formula, a squared plus b squared equals c squared. Notice that the word formula contains the word form. It's just that in mathematics and in algebra and geometry specifically, the content are numbers, the numbers 3, 4, and 5. Okay, but let's get down to logic. So again, we're dealing with form and content here, and what we're going to do is go put this in a kind of formal representation eventually. So we begin with the idea of logical connectives. It is connectives that are going to allow us to eventually symbolize these things in an abstract way. Connectives are basically logical functions. They perform certain logical functions, which we'll see later in this chapter have implications for truth values. There are two types. There are unary and binary connectives. The word unary is just derived from the Latin for one. The word binary contains the word bi, which means two. And a unary connective basically only applies to one statement. So we'll see that negation is really the only unary connective that we'll be dealing with, whereas binary connectives put two statements together. Here are some examples. So conjunction is one binary connective, because as we'll see, conjunction puts together two statements, and negation is our unary connective, because negation will only apply to one statement. Here's an example from English, from language, from content. Here we have two statements conjoined. John went to the movies and John went to the beach. So we have two separate statements here that are conjoined, and so this is an example of the word and here is the connective, because that's what's bringing them together. And remember, that's going to be symbolized by the dot. So here's an example of negation. John did not go to work. This word not is what in English expresses the negation, which we will shortly see. It's the tilde that symbolizes or formalizes that word. But John did not go to work is basically just a concrete example of negation. Let's get into negation more specifically. So what do we mean by negation? Well, negation is basically the opposite of an affirmation. And this basically raises the question, what is an affirmation? An affirmation is, in a sense, a kind of yes saying. So if I say, for example, my computer monitor is on my desk, or if I say the computer monitor is on my desk, that's an affirmation. That's a kind of yes saying. Because if somebody were to ask me, is your computer monitor on your desk, I would say yes. Negation is the opposite of that. And that's because negation would be the not. So if I said my computer monitor is not on the floor, that would be a negation. Or if I said my computer monitor is not on the desk, that would also be a negation. So notice that the word not is involved with negation. And as I've said earlier, it's the tilde that we're going to use to represent that function, to represent negation. So here are some examples. John went to the movies. If we let M represent that statement, John went to the movies, tilde M, not M, would represent John did not go to the movies. Notice that I've chosen the letter M to specifically represent the statement John went to the movies. And notice that M is capitalized. We will always capitalize letters that represent specific statements. And John went to the movies is a specific statement. If we're talking about statements in general, we'll use lowercase letters. And that's when we think of them kind of in terms of variables. But to talk about specific sentences, we use a capital letter. This is similar in algebra. If you're talking about a specific number, you actually refer to the number like 3, 4, 5, -8, or whatever. But if you want to talk about a number in general, you would do it with a variable, right, with an x. So we have the same similar thing going on here. A specific capital letter represents a specific statement. Okay, here's another example. John went to the beach. So if we let B represent that specific statement, the negation of that would be John did not go to the beach. And so that would be symbolized as tilde B. Okay, so one last thing here is that there are other ways of expressing negation. I could say it is not the case that. So for example, it is not the case that John went to the movies. Or it is false that John went to the movies, right? And that would be just another way of just basically expressing negation, right? Okay, let's go to conjunction. What are conjunctions? Conjunctions is basically when two statements are being put together in a kind of inclusive way. It's kind of analogous to addition in mathematics. We put them together in a way that includes both of them. So in English, the word and can be used for conjunction, but you could also use other words like but. John went to class, but John went to the movies, right? So there are different ways of doing that in English. And in logic, we'll have a specific symbol for that. Okay, John went to class is a conjunct, and John went to work is a conjunct. So both statements here do have a name, and they're both conjunct. And then the whole thing, John went to class and John went to work, is a conjunction. Okay, so it's the dot that we're going to use here to symbolize the conjunction. So let's look at an example. John went to class. If we let C symbolize or represent John went to class, and we let W symbolize John went to work, well, then the whole conjunction C dot W would symbolize John went to class and John went to work. So in this class, we're using the dot to do that. Some other courses or some other textbooks might use a different symbol, but we're going to use a dot. Okay, let's look at our last binary connective, and that's disjunction. Disjunction is basically a way of putting statements together in a kind of exclusive way. So just as conjunction it does it in a kind of inclusive way, think of disjunction as doing this in an exclusive way. And so a way to think of things exclusively is to use the word or, right, in English. So John goes to the movies or he goes to class. This kind of presupposes that one is excluded, right, that he can only do one. He can't do both. And that's what I mean by thinking of this in terms of exclusive terms. But in English, it's the word or that expresses that disjunction. And these parts have name. So John goes to the movies is a disjunct. He goes to class is another disjunct. So just like we have conjunction had two parts, two conjuncts, this one has two parts and they're disjuncts. Okay, so we use the wedge to symbolize the or. So let's look at an example. John goes to the movies. We would use the M to symbolize that specific statement, and John goes to class, we would use the C, the capital C, to symbolize that statement. So then the whole statement, John goes to the movies or he goes to class, would look like this. M wedge C would symbolize or formalize that whole disjunction. Okay, let us do a little practice mini quiz here, which is going to be helpful for your homework, because in your homework what you're going to be doing is basically translations. So what we're going to do is we're going to symbolize or translate these 5 statements. So you can pause your computer now, pause the video now, and do these, and then when you're ready to check your answers, go ahead and hit play. Okay, so here are the answers. Number 1 is not H tilde H. Honda does not manufacture SUVs. Notice that there's the word not, so that should signal negation. If we let H symbolize Honda manufactures SUVs, then Honda does not manufacture SUVs would be symbolized by not H. By the way, I chose the letter H to represent that specific statement, but any letter can be used. The letters here are arbitrary. We could have also used M to symbolize number 1. So you can pick your own letters. You want to be consistent with them, however, and you want to be careful, because if you're dealing with multiple letters, multiple statements, you're going to want to have a unique letter for each statement, right? Okay, number 2 is L dot N. So if we let L represent Los Angeles is a large city, and we let N represent or symbolize New York is a very large city, then L dot N would represent both Los Angeles and New York are very large cities, right? Okay, number 3, not both Walmart and Target are supermarkets. This can be done in either one of these 2 ways. We could have the tilde outside of the parentheses, W dot T, because what that would mean is that the negation is applied to that specific conjunction, right? So inside the parentheses we have the conjunction Walmart is a supermarket and Target is a supermarket, right? That's what that conjunction would mean inside the parentheses. And what's going on here is that the whole thing is being negated, right? And so that's why we would have the tilde outside. That's why that would be correct. But also the other answer here on the right equally symbolizes or formalizes that statement, right? Because saying not both Walmart and Target are supermarkets is equivalent to saying neither Walmart nor Target are supermarkets, right? And that's what tilde W wedge not T symbolizes. It's neither nor, right? Okay, so that's number 3. Number 4 is M wedge B. So if we let M symbolize McDonald's has low prices, and we let B symbolize Burger King has low prices, then basically what 4 is saying is either M or B, right? And there's the word or that tells us that we need the wedge. Okay, and then the last one, number 5, can also be done in 2 ways. Neither Netflix nor the video store have the movie that I want to watch. The first one on the left, we have the tilde outside of the N or S, and that's because inside the parentheses it's basically saying Netflix does not have the movie that I want to watch, or it's basically saying neither Netflix has the movie that I want to watch nor the video store has the movie that I want to watch. And so there is a disjunction inside the parentheses, and what the tilde outside of it does is basically saying that there's a negation that applies to both, right? That neither of them has the movie that I want to watch. Okay, and so why is the answer on the right correct? Well, saying neither Netflix nor the video store have the movie that I want to watch is logically equivalent to saying Netflix does not have the movie that I want to watch and the video store does not have the movie that I want to watch, right? Those basically mean the same exact thing logically, right? So that's why that is also correct. Okay, so make sure that you can do this, because this is what your homework will be about. You need to be able to translate these accurately, correctly. Okay, that is it for this for part 1. In part 2 of section 6.1, we're going